Hey everyone, and welcome. So, we all love building things in Java, right? But you've probably hit this problem. You build this awesome app, you run it, it works perfectly, and then you close it. And just like that, all your data is gone, vanished. Today, we're going to fix that. We're going to pull back the curtain on how Java applications talk to databases to make sure your data sticks around. I want you to think about your running Java app like this. It's its own little island. While it's running, it's got everything it needs. All its variables, its objects, everything's in memory. But the moment the program stops, well, the island sinks. Everything on it is lost to the void. So to save all that valuable information, our island needs to connect to the mainland, to the world of persistent data. But how? Well, we build a bridge, of course. And in the world of Java, that bridge is called JDBC. JDBC stands for Java Database Connectivity, and it's basically the official standard-issue bridge-building kit that comes with Java. It gives you all the tools you need to connect your application island to pretty much any database mainland you can think of. MySQL, PostgreSQL, Oracle, you name it. Okay, so before any great construction project, you need a blueprint, right? You need a plan. When it comes to JDBC, there are really two main blueprints, two architectural models for how we can design this connection. So on one hand, you've got the two-tier model. I call this the direct bridge. It's exactly what it sounds like. Your Java app talks straight to the database server, no middleman. This is super simple, really straightforward, and honestly, it's perfect for a lot of basic applications. Then you have the three-tier model, the managed bridge. Here, your app doesn't talk to the database directly. Instead, it talks to a middle-tier server, and that server talks to the database. It's a bit more complex to set up for sure, but that middle layer is incredibly powerful. It's where you can put all your business logic, handle security, manage connections, all the heavy lifting. So we have our blueprint. Now it's time to choose the actual materials we're going to use to build our bridge. In the JDBC world, these materials are called drivers. You can think of a driver as a specialized translator. It's the piece of software that takes your Java code and translates it into a language that your specific database can actually understand. Now, if you look back through history, you'll find there are four main types of these drivers. You can almost think of them as different generations of bridge technology. There's the old Type 1, the JDBC ODBC bridge, then Type 2, which use native APIs, and then came the much more modern all-Java drivers, Type 3 and Type 4. But look, while it's cool to know about all four, for pretty much anything you're going to build today, the choice really just boils down to one key difference, the old way versus the modern way. And here it is. On the left, you have the Type 1 driver, the helper bridge. See, this one was clever for its time, but it actually relied on another technology called ODBC to do the talking. It wasn't a pure Java connection. Now compare that to the Type 4 driver, the pure Java bridge. This is the one you'll almost always use. It's written completely in Java, it's self-contained, it talks directly to the database, and because it's pure Java, it works on any platform. It's faster, more efficient, and it is absolutely the modern standard. All right, we've got our architecture, we've picked our modern Type 4 driver materials. So how do we actually build this thing in our code? Well, you'll be happy to know it's a super logical process that really just comes down to four basic steps. Here they are, the four magic steps. First, you load the driver. That's like telling Java, hey, we're using this specific bridge building kit. Second, you get the connection. This is where you actually build the bridge and open it for traffic. Third, you create a statement. Think of this as the truck that's going to carry your cargo across the bridge. And finally, you execute the query. You load that truck up, send it on its way, and wait for it to bring back the goods. Let's see what this looks like in actual code. Step 1 is literally this one line of code. It looks a little weird, but all class.forName does is tell the Java virtual machine, hey, go find this driver class and load it into memory. Once that line runs, the driver is registered with the system and ready to be used. That's it. Step 1, done. Step 2 is where the magic happens. We use this class called Driver Manager, and its getConnection method. You give it three things: a special URL that points to your database, a username, and a password. If everything checks out, boom, it gives you back a connection object. This con variable here, that's it. That's your live active bridge to the database. Okay, bridge is built. Now we need our delivery truck, right? On our new connection object, con, we call the createStatement method. This gives us back a statement object. This st variable is now our messenger, our vehicle, ready and waiting to transport any SQL command we want to send. And here's the final step in all its glory.
You take your statement object, st, and you call a method on it, like execute query. And what do you give it? Just a string with your plain old SQL command. That's it. The command gets sent across the bridge, the database runs it, and the results get sent right back to your application.
So the bridge is officially open for business, but what kind of traffic can we send across? Well, it really boils down to two main types of commands, two kinds of trips our truck can make.
The two big ones you need to know are execute query and execute update. You use execute query whenever you're reading data, so for all your select statements. You're asking for information. And what it gives you back is something called a result set, which is basically a handy Java object that holds your data in a nice, neat table. Now, for everything else, for when you want to change data, insert, update, delete, you use execute update. This method doesn't return data. Instead, it just returns a number, an integer, that tells you exactly how many rows you just changed in the database. Super useful. And there you have it. That's the core of it. By loading a driver, getting a connection, creating a statement, and executing a query, you've done it. You have successfully built a bridge. Your Java application is no longer this lonely, isolated island. It's now fully connected to the vast, powerful world of persistent data. So now you have the blueprint, you know what materials to use, and you have the 4-step construction manual. The only question left is, what are you going to build? What amazing data are you going to connect your applications to? The bridge is yours to create. Thanks for joining me.